Let's be honest. How often do you really think about the road you're driving on? You know, it seems so simple, just a black surface that gets you from point A to point B. But that simple surface, it's actually a super complex, highly engineered system we rely on every single day. So let's dive in and uncover the surprising science of the asphalt road.
First, let's just try to wrap our heads around the scale of this. That blacktop isn't just common, it is absolutely dominant. Asphalt covers about 90% of all paved surfaces around the entire world. That is just an incredible amount of infrastructure that has to be built, maintained, and, well, eventually replaced.
And that leads to some pretty big questions, right? How in the world do engineers design these roads to take a constant beating from traffic and weather? And what happens when they start to break down? We're going to follow the complete life cycle of a road, from the day it's born all the way to its rebirth.
Okay, so it all starts, kind of like any great creation, with a recipe. You can't just throw some rocks and tar together and call it a day. Nope. Building a road that's going to last takes a precise formula, one that's picked carefully from a surprisingly diverse recipe book.
So the two essential ingredients are bitumen and aggregate. Bitumen is that black, sticky stuff that comes from crude oil. Just think of it as the glue. And the aggregate? Well, that's the muscle. It's a carefully mixed blend of crushed stone, sand, and gravel that gives the road its structural strength. The real magic is all in how you combine them.
And what's really interesting is how temperature basically defines the recipe. It creates this trade-off between how durable the road is, how much it costs, and its environmental impact. Hot mix is the industry workhorse, right? It's heated to over 150 degrees Celsius for maximum strength. Then you've got warm mix, which is a greener option, made at lower temps to save fuel and cut emissions. And finally, cold mix. You apply it without any heat, which is perfect for quick patches and for remote areas where you can't exactly set up a whole hot mix plant.
Now, to make that bitumen glue actually workable, you have to liquefy it. The old-school way used a solvent, creating what's called cut-back bitumen. But that process releases all these nasty volatile compounds. The modern, much more eco-friendly way is called bitumen emulsion, where the bitumen is just suspended in water. And that shift, it's a huge deal. It makes building roads safer for workers and way, way better for our air quality.
So once a road is built, its life begins, and so does the battle against its greatest enemies. And how well it fights that battle really depends on the recipe chosen at the very beginning. Day after day, it's dealing with the stress of traffic and weather, but its number one enemy is something you might not expect: water.
This is the classic, tragic story of a pothole. It all starts with these tiny, almost invisible cracks from the sheer weight of vehicles. Water sneaks in, and if you're in a cold climate, it freezes. When water turns to ice, it expands, and that forces the cracks wider and deeper. This lets more water get in, weakening the base underneath until, bam, the surface just collapses under traffic. A tiny little problem turns into a major hazard.
So here's the key takeaway. If water is the enemy, the absolute best way to make a road last is to never let the enemy through the gates in the first place. Proper pavement drainage, which is a critical part of the initial design, is all about getting water off the surface and away from those underlying layers. It is, without a doubt, the single most important factor in preventing a road from failing before its time.
But, you know, even the best-built roads eventually wear out. In the past, that meant digging the whole thing up and hauling it off to a landfill. Not anymore. Now, we get to the most amazing part of a road's life: how modern roads don't just get demolished, they get reborn.
The tech that makes this possible is called full-depth reclamation, or FDR. It's an incredible recycling process that happens right there, in place. Instead of removing the old road, you use the old road as the main ingredient for the new one.
Okay, here's how it works. First, this massive machine called a reclaimer drives over the old, beat-up road. It has this powerful milling drum that just grinds up the entire asphalt layer and even some of the base underneath it, turning the failed pavement into a reusable material right on the spot. No trucking it away.
Next, a stabilizing agent gets mixed in. This could be something like cement or lime. And this stuff doesn't just bind the old material together, it actually chemically transforms it. It creates a new base layer that's often stronger and more stable than the original road ever was. Now this step is absolutely critical: compaction. A whole series of heavy rollers press down on this new mix, squeezing out all the air and water to create a super dense, solid foundation. You have to get this right for the road to perform well long term.
And finally, for the finishing touch, a fresh new layer of asphalt is paved right on top. What you get is a brand new, smooth, durable road
built directly on a foundation made from its former self. The cycle is complete. It's just brilliant. And the benefits? They're massive. You're saving natural resources because you don't need as much new stone and oil. You're saving huge amounts of fuel by not having to truck materials all over the place. It's cheaper, it's faster, and it gets rid of all the old cracks and flaws while fixing the road's shape for better drainage. It's a total win-win-win.
So we've looked at the recipe, the enemy, and the rebirth. But what's next? Let's look ahead for a minute, because the future of our roads sounds like something straight out of science fiction.
Now, before we get too carried away, it's really important to remember this. All these amazing innovations, they're built on the bedrock of good engineering. The basic principles, strong design, good materials, and especially drainage, will always be the most important part of building a road that lasts.
Okay, with that foundation in place, now we can ask the really big question. What if we could stop those tiny little fatigue cracks, the ones that grow into potholes, from ever getting bigger in the first place? What if the road could heal itself?
And this isn't just a dream, it is actually happening in labs right now. Researchers are trying out things like encapsulation, where they mix these microscopic capsules full of a special oil into the asphalt. When a tiny crack forms, it pops the capsules, releasing the oil to seal the damage. Another wild idea is induction heating, where they add steel fibers to the mix. That allows a special machine to heat the road from the outside, melting the bitumen just enough to flow back together and close up any cracks.
So the next time you're driving, think about that. The road beneath you has this really complex past and an even more incredible future. We've gone from a simple recipe of stone and oil to a sustainable, recyclable system, and we're heading towards a future where that road might not be a passive surface at all, but an intelligent system, actively working to repair itself. Now that is a journey worth thinking about.
Don't forget to like and subscribe for more How Meets History.